Hi, it's Mrs. Seitz, and today what you're going to be doing is first we're going to be estimating some non-perfect square roots, and then we're going to be comparing some um, real numbers and ordering them. You're also going to need a calculator for today's lesson, pretty much for the second part of today's lesson, so you're going to need to have that nearby. We're going to start out by approximating some square roots. So you might want to remember that these are some perfect square roots. And we're going to actually align these perfect square roots on a number line. So you might remember that the square root of 1 is 1. The square root of 4 is 2. We know that the square root of 9 is 3. So we're going to write that above here. The square root of 16 is 4. The square root of 25 is 5. The square root of 36 is 6. The square root of 49 is 7. We already have that the square root of 64 is 8, but we have to write that the square root of 64 above it. The square root of 81 is 9, and I'm going to write the square root of 81 above it. And I know that the square root of 100 is 10. I'm also going to mark down here that the square root of 0 is 0. All right, I have all my roots lined up, my perfect square roots in order from least to greatest on a number line. And one thing that you notice is the number inside the square root sign is also actually in order from least to greatest. I'm going to use that to my advantage because when I have to estimate a non-perfect square root, I'm going to actually use that to my advantage. So what you have to do is anytime you have a number that's not a perfect square root. So for example, like the square root of 52, I'm going to place that non-perfect square root on the number line between the two perfect square roots that would fall in between. So one bigger and one smaller. So the square root of 52 goes in between the square root of 49 and the square root of 64. So that would mean that my answer is going to be somewhere in between 7 and 8. So I'm going to write that down. The square root of 52 is in between the square root of 49 and the square root of 64. So when I'm thinking about in terms of what my answer is going to be, I want to see, I know that the square root of 49 is 7, and I know that the square root of 64 is 8. So when I'm trying to estimate what the square root of 52 is, I want to see which number it's actually closest to. So is 52 closer to 49, or is 52 actually closer to 64? So 52, remember, is closer actually to 49 because it's only 3 places away. Whenever we're talking about distance, right, 52 is much further away from 64, right? So it's 3 spaces away to get to 49 as opposed to 12 spaces away to get to 64. So when I'm approximating the square root of 52 to the nearest integer, which remember is your positive or negative whole number, I would use these approximately equal to symbols. So it's an equal sign that looks like 2 wavy lines. And I would say that it's approximately closest to whatever the answer is to the square root of 49, which would be approximately equal to 7. And I can check to see if my answer is pretty close. So on my calculator, I'm going to check right now and see how I'm doing with this. So I can hit the second button, square root. So I'm going to type in the square root of 52, hit enter. Now remember, if it gives you a root button back, you can hit the double arrow button and see what the decimal approximation would be. So this would be about 7.2. So I found an approximation that would be pretty close. And again, we would need to see your supporting work to make sure that you did this correctly. So your work would be showing the perfect roots that would fall one below and one above. All right, let's try a couple of these now. So let's take a look at these examples and see which one of these would be one above, one below, and we want to estimate each one of these non-perfect roots to the nearest integer. So the square root of 33 would fall in between, looks like the square root of 25 and the square root of 36. So I'm going to write that down. Square root of 25, square root of 33, which is the one we care about, and the square root of 36. Okay, now I know it's going to take me 3 units to get to 36. I know it's going to take me 8 units to get to 25. So that means I know my answer to the square root of 33 is going to be closer to whatever the root of 36 is. So whenever I'm approximating the square root of 33, it's going to be approximately equal to whatever the square root of 36 is, and that answer is going to be approximately equal to 6. Okay, and again, you can check your answer to see if you're right. So square root 36, or I'm sorry, square root of 33, hit the double arrow button, it's about 5.7, and if we would round up, the nearest integer would be about 6. All right, let's try out the next. So the square root of 85. So again, what two perfect roots does it fall between? So the square root of 85 would fall in between the square root of 81 and the square root of 100. So I'm going to write down the square root of 81 and the square root of 100. And I'm going to put the square root of 85 in between. 85 is definitely closer to 81 than it is 100. Okay, so when I'm approximating the square root of 85, I'm going to say it's approximately equal to, well, let's see, the square root of 81 I know is equal to 9. So when I'm approximating the square root of 85, I'm going to say it's approximately equal to 9. Okay, let's do a square root of 190. Well, for the square root of 190, I don't go up that high. So I'm going to have to think about some other perfect square roots. So the square root of 190, if I would keep listing them, it's actually between the square root of 169 and the square root of 196. So when I'm taking a look at my perfect roots, 190 would be much closer to the square root of 196 than it would be the square root of 169. So that would mean that my answer would be approximately equal to 14. All right, and this also works for negative numbers as well, but you just want to make sure that you're transferring the negative sign into your final answer. So the square root of 7 falls in between the square root of 4 and the square root of 9. I know we're talking negative numbers, but again, we're just going to transfer that into our final answer. So I'm going to say, let's see, we are 3 units away on this side, and we are 2 units away on this side. So we're kind of in between on this one. But we are technically a little bit closer to the square root of 9 side. So I'm going to say we're approximately closer to this side. So we're going to say the square root of 7 is approximately equal to, let's see, the square root of 9 is equal to 3. So the square root of 7, or I'm sorry, the negative root of 7 is approximately equal to negative 3. And again, let's test it out to make sure we're good. If we type this in, let's see, the square root, we'll actually make sure we type our negative signs. The negative root of 7 would be approximately equal to negative 2.64 something. So again, we're much closer. We're kind of in the between, but again, we're leaning more towards negative 3 than we are towards negative 2. So negative 3 seems like a reasonable estimate. All right, so that was the first part of your lesson. The second part of your lesson today is going to be comparing and ordering real numbers. So again, remember a real number represents a value on a number line. So you compare and order real numbers, you can place the numbers on a number line and determine your values. You can change these real numbers to decimal approximations to make comparing and ordering much easier. So you can do that by rewriting each number as a decimal approximation and then compare each set of numbers using less than, greater than, or equal to. So what I'm going to do is I'm going to change each one of these into a decimal, line up the decimal points if needed to, and then use less than, greater than, or equal to help me out. So square root of 6 is my first value. Again, hit the double arrow button, and I can see that that's going to be about 2 point, I'm going to take that out a couple places, 2.49 something. Okay, and then my next one is 2 1/3. And again, I'm going to hit the double arrow button. I'm going to line this up, and I'm going to go back to my slide so you guys can see this is 2.3 repeating. When you line this up, make sure you're lining everything up with your decimal point. So my decimal point is nice and lined up. Okay, so I want to see, okay, my ones place value position is exactly the same. It's the tenths place value position that we start seeing some changes. So I can see right now that in the tenths place value position, the 2 1/3 is smaller than the square root of 6. So when I start making that comparison, I'm going to say that the square root of 6 is greater than 2 1/3. All right, we're going to do the same thing now, but we have to be careful, remember, because we're dealing with negative numbers. So let's start making the decimal approximations for negative square root of 12 and negative pi. So I'm getting negative 3.464. I'm going to leave it at that for now. Okay, and then for pi, I have negative, and then I'm going to look for pi on here. There it is. Negative 3.1415. I could keep going on forever. Okay, but remember when we're on the negative side of things, okay, the closer you are to 0, the better. Okay, that means you are larger. So if we're thinking about a number line, okay, where this is 0, okay, if we're thinking about, this is where negative 3 is, this is negative 3.1, this is negative 3.2, negative 3.3, negative 3.4. So negative 3.4 is actually much less than negative 3.1. Okay, so when we think about things, negative 3.1 is actually bigger than negative 3.4 because negative 3.4 is further away from 0 than negative 3.1. Okay, and again, we're looking at this on the number line, and we're making a comparison with negative 3.1. If you need to think about it instead of negative 3.1, think about it as negative 31, and think about it as negative 34. If you owe somebody $31, it's not as bad as owing somebody as $34, right? Okay, take a look at this next one. We have negative 0.24, and now we're going to change negative 3/7 into a decimal. So I'm getting negative 0.42 and then 8 something. But really, when I think about the comparisons, I'm really thinking about here's 0, and I'm going to go back to the slide so you guys can see this, right? I'm looking at the tenths place value position. I can see that I'm really looking at the difference between a 2 and a 4. So think about it like this. Negative 0.2 is here. Negative 0.4 is here. Negative 0.2 is much closer to 0 than negative 0.4. So this would be greater than. Ordering these is also the same. So we want to make sure we put these numbers in order from least to greatest by first comparing with their decimal approximations. So right now, take some time and put these numbers into their decimal approximations, and let's see if we put this order in correct order from least to greatest. Okay, so when we're starting to take a look to see if we got these right, if you take a look at 5 and 1/4, that'd be 5.25. 2 pi is 6.28 something, and keeps going. And the square root of 22 starts out at 4.69, and that keeps going on forever. If we look at the ones place value position, that actually kind of is the telltale order there from least to greatest. So the square root of 22 would start out first, and you want to make sure you put these in order, starting out with the original values. So don't actually use the decimals, use the original problems. So the square root of 22 would come first because that was the 4.69. Then the 5.25, which would be the 5 and 1/4. Then the 2 pi, because that one was the largest in the ones place value position. When I started converting these into decimals in the second part of the problem, negative 10 and 2/5 was negative 10.4. So this one would actually be our biggest one because this is going to be actually closest to 0. So I'm going to leave this one here at the end. I'm deciding right now which one's the smallest. Is it going to be negative 12.05 or is it going to be negative square root of 145? To figure this out, I'm looking to see at the hundredths place because when I changed the negative square root of 145, it ended up to be negative 12.041 something. Okay. Well, remember, the bigger your number is as a negative, the further away it is from 0, meaning that it's a smaller number. So this negative 12.05 is actually the smallest number. Then the negative root of 145 would come next because negative 12.05 would be the 5 makes this smaller than the negative 12.04 something. All right, so to make sure you had everything for today, if you're comparing or ordering any real numbers, make sure you're changing things to decimal approximations and lining everything up by their decimal point. To make those comparisons, especially with negative numbers, you might want to use a number line. The other part of today's lesson was estimating those non-perfect roots. You need to make sure that you are using those perfect square roots according to the number line. You want to use whatever the two perfect roots that it falls between to help you to approximate which one it is going to be. Whatever one it's closest to is going to be your answer. And always use those, I like to call them the squiggly equal signs to show what you would be approximately equal to.